Hi friends, in this video we are going to analyze full wave rectifier through their performance parameters. So here full wave rectifier we are going to consider both center tap rectifier as well as bridge rectifier, because maximum performance parameters for both these rectifiers are same. So the first parameter is DC value of load current. Which we will denote as IDC. It is the average value of a load current flowing through load resistance RL. Before proceeding, I will write a equation of I0. So I0 equal to Im sin theta, and this is the same as input current and it exists from 0 to pi. In order to understand this equation, I will draw current waveform once again. So it is like this: 0 to pi, current is flowing because D1 conducts in center tap rectifier, and in bridge rectifier D1 D2 both conducts. Similarly, in negative half cycle I am getting a waveform because of D2 conducts in case of a center tap rectifier, and for bridge rectifier D3 D4 conducts. So if I have to write equation of this current, it will be I0 equal to Im sin theta, and this exists from 0 to pi. So let us find out its average value, which is DC value IDC. 1 upon time period integral 0 to pi I0 d theta. So this is equal to 1 upon pi integral 0 to pi, and I0 is Im sin theta d theta. So if I simplify further, I will get IDC equal to Im by pi integral 0 to pi sin theta d theta. Integral of sin theta is minus cos theta. And if I apply limits, I will get minus cos pi minus cos 0. So this is equal to Im by pi minus cos pi is minus 1, minus plus cos 0 is 1. So ultimately it will be 2 Im upon pi. So this is the average value or DC value of output current for full wave rectifiers, whether it is center tap or bridge. Let us move ahead to next parameter, and that is RMS value of load current. It is a root mean square value of load current flowing through load resistance, and given as IRMS equal to root of 1 upon pi integral 0 to pi I0 square d theta. So it is equal to root of 1 upon pi integral 0 to pi I0 is Im sin theta. So I0 square will be Im square sin square theta d theta. So this is equal to root of Im square upon pi integral 0 to pi sin square theta I will write as 1 minus cos 2 theta upon 2 d theta. Further solving will give me root of Im square upon 2 pi and integral of 1 is theta, integral of cos theta is sin 2 theta divided by 2, limits are 0 and pi. So, let us apply these limits. So, I will get IRMS equal to root of Im square upon 2 pi, upper limit is pi. So, it is a pi minus sin 2 pi by 2 and lower limit is 0. So, it is 0 minus sin 0 upon 2. Sin 2 pi is 0 and this entire term is 0, leaving behind only pi. So, IRMS equal to root of Im square upon 2 pi multiplied by pi. Pi get cancelled and finally I will get IRMS for full wave rectifier as Im upon root 2. Let us move to next performance parameter and that is output voltage. It is a V0. Remember, output voltage of rectifier is always DC voltage because purpose of rectifier is a conversion from AC voltage to DC voltage. So, VDC is the voltage across load resistance RL given by IDC multiplied by RL, and IDC we have calculated as 2 Im by pi. Im is nothing but Vm divided by number of resistance come in series, meaning there will be Rs, there will be Rf and there will be load resistance RL. What is Rs? Is the secondary winding resistance of a transformer. What is Rf? It is a forward resistance of conducting diode and load resistance is RL. Normally this Rs and Rf is very less than RL. So, I can neglect this and I can get Im is Vm upon RL. Let us substitute this value over here, we will get VDC as 2 upon pi, instead of Im I will substitute Vm upon RL multiplied by RL. So, this RL will get cancelled and finally I will get VDC as 2 Vm upon pi. Let us move to the next performance parameter and that is rectifier efficiency. It is a ratio of DC output power to AC input power. It is an indication of how good rectifier is converting AC into DC as far as power is concerned. So, this is equal to PDC upon PAC. Now, PDC is nothing but IDC square into RL. IDC we have calculated as 2 Im upon pi. and PAC is nothing but IRMS square multiplied by RL, and IRMS we got as IM upon root 2. So, if I substitute these values, I will get rectifier efficiency as 4 Im square upon pi square multiplied by RL divided by Im square by 2 multiplied by RL. So, here RL get cancelled, also Im square get cancelled, and what I will get over here is this 8 upon pi square, a constant term I will get. If I solve, I will get rectifier efficiency as 0.812. If I convert this into percentage, so percentage rectifier efficiency will be 81.2, which is quite higher. It is double that of half wave rectifier. Let us move to the next performance parameter, and that is ripple factor. The output of rectifier is not perfect DC, it is pulsating DC. What does that mean? It has some AC component present along with the DC, and that component is called as ripple. So, AC component present in rectifier output is called as ripple, and ripple factor is the ratio of that component with DC component, and it is given as root of IRMS upon IDC the whole square minus 1. IRMS we have already calculated as IM upon root 2, and IDC is 2 Im upon pi. So, here Im square get cancelled, I will get this equal to pi square upon 8 minus 1, a constant term I will get, and if I solve this I will get ripple factor 0.48. In percentage, percent ripple present in full wave rectifier output is 48, which is lower than that of half wave rectifier where it is 121%. So, from 121% we have reduced our ripple factor to 48% in full wave rectifier. Let us go to the next performance parameter, and that is peak inverse voltage of a diode. PIV. It is defined as the maximum voltage which is reverse direction. So, I would say maximum reverse voltage that can be applied across the diode without damaging it. So, for center tap full wave rectifier, PIV is twice Vm, 2 times the maximum voltage of the supply, and for bridge rectifier PIV is Vm. Let's go to next performance parameter, and that is transformer utilization factor. Abbreviated as TUF. It indicates the utilization of a transformer and given as DC power delivered to the load upon AC power rating of transformer secondary. So, this is equal to IDC square multiplied by RL because it is a DC power, and AC power rating of secondary of a transformer is Vrms multiplied by IRMS. So, if I solve, I will get IDC we have calculated as 2 Im by pi, Vrms is Vm by root 2, and for full wave rectifier IRMS is also Im by root 2. Now, if I solve further, it will be 4 Im square by pi square multiplied by RL divided by Vm, I can write as Im into RL. So, that will give me 4 Im square by pi square multiplied by RL divided by Im square multiplied by RL upon 2. So, RL will get cancelled, Im square will also get cancelled, and that will give me transformer utilization factor as 8 upon pi square. If we solve, it will be 0.812. But this value, it depends upon whether primary is also used same as the secondary, which is the case in bridge rectifier. So, I can say over here transformer utilization factor for bridge rectifier equal to 0.812. Transformer utilization factor for bridge rectifier will be 0.812, but that won't be the case for center tap full wave rectifier. Why? Because the primary of the transformer is feeding two half wave rectifiers separately in center tap full wave rectifier. What does that mean? One rectifier, which will be half wave rectifier, will be feeding by complete primary winding of a transformer. Hence, transformer utilization factor for primary side will be 2 times transformer utilization factor of half wave rectifier. So, this is equal to 2 into 0.287, which is nothing but 0.574. Now, here to get a average utilization factor of a transformer for center tap rectifier, we need to take an average of TUF because of primary side and TUF because of secondary side. So, that will be 1 by 2 into 0.574 plus 0.812. If you solve this, you will get average TUF equal to 0.693. So, transformer utilization factor for center tap rectifier is lesser than bridge rectifier because of this fact. The primary of transformer is feeding two half wave rectifiers separately in center tap full wave rectifier. Thank you.